Pushing a drill bit miles into the Earth's crust requires a massive orchestration of heavy machinery, extreme pressure, and tens of millions of dollars. Historically, this entire operation suffered from one distinct flaw. The engineers on the surface had no real-time way of knowing what was actually happening at the bottom of the well. They were effectively drilling in the blind. This chart shows the old timeline. Crews pushed the bit forward, then completely stopped to take measurements and read delayed reports. Every stop compounded the financial cost. If the drill drifted off course, the crew only found out after the damage was done. OmniPetro eliminated this exact vulnerability by stripping away the gap between gathering data and taking action. They call the solution digital drilling. They wired the physical rig into a high-speed network, allowing it to continuously broadcast torque, pressure, and vibration metrics straight to the surface while the machinery is still moving. The process relies less on mechanical force and entirely on a continuous, live loop of information. To see how that data originates, we follow the drill string down through thousands of feet of solid rock, right to the active bit. Mounted directly behind the cutting teeth are two specific sensor packages: measurement while drilling, or MWD, and logging while drilling, LWD. While the bit spins under pressure, these tools emit acoustic and electromagnetic signals into the surrounding rock. They measure the exact trajectory, rock density, porosity, and electrical resistivity. As signals bounce back, the readings immediately translate into a continuous stream of digital telemetry. That telemetry shoots from the crushing depths of the wellbore all the way up to the surface in fractions of a second. These sensors allow the bit to operate as a highly sensitive diagnostic probe, completely removing the guesswork from the subsurface. That incoming feed arrives here, in OmniPetro's Smart Operations Room. Human experts monitor the telemetry against complex 3D holographic models of the rock below. Sitting between the raw data and the human engineers is an artificial intelligence layer that constantly processes the telemetry. The AI plots the ideal pre-planned trajectory in white, instantly comparing it against the live, wandering dotted drill path. By recognizing subtle changes in pressure and vibration patterns, the software flags microscopic deviations, predicting mechanical failures well before the metal binds up. When the AI spots a drift, it instantly proposes a course correction to keep the bit inside the most productive zone. The drilling engineer reviews the math, then approves the adjustment. That command shoots right back down the well. Using real-time well steering, the mechanical systems behind the bit adjust their angle of attack mid-rotation, carving a precise curve without pausing the drill. This unbroken loop, data up, analysis on the surface, and steering commands down, replaces blind plunging with precision engineering. Operating an oil rig is no longer a reactive battle against unknown geology. It is a live, continuous dialogue with the Earth. By adjusting to the rock in real time, OmniPetro's engineers drastically reduce the instances of dangerous blowouts, stuck drilling equipment, and entirely missed reservoirs. Now they are moving toward the next iteration of the technology, fully autonomous, self-steering wells. Soon, these drilling systems will interpret shifting rock densities and optimize their own trajectory on the fly, requiring only passive supervision from the human crews on the surface. For now, the real-time adjustments have done their job. The bit punches through the final layer of dense caprock, accurately penetrating the target reservoir. But reaching the oil is only half the problem. Now that the well has tapped into millions of gallons of highly pressurized viscous fluid, how does OmniPetro safely control that violent surge back to the surface?